You know those detective movies where the investigator has a corkboard covered in photos, completely tangled with a red string? They don't do that because it looks cool. They do it because the simple list of suspects doesn't solve the crime. The connections do. Traditional databases just give you the list of suspects. Graph databases give you the red string. Graphs represent data with nodes and edges. The nodes are the entities, and the edges are the relationships between them. Here's a classical example where graph representation shines. How do we plan the most optimal, shortest path across multiple addresses while accounting for deadlines, different transportation modes, and traffic? That's a graph. The addresses are the nodes, the paths are the edges. Let's take this to the business world. Supply chain failure. You have a network of suppliers and warehouses, and something like a natural disaster disrupts one of the nodes. It will be important to quickly understand your supply chain relationships and its blast radius impact. There are many more examples where your existing data can benefit from being represented as a graph. To understand how parts impact finished products, or better understanding customers or employees by creating a social representation that allows you to connect a person with their context and history. Now that we understand what a graph is and how it fits in representing your data, I have great news for you. With BigQuery, you get the best of both worlds: the structure of relational data and the rich connection of graphs. BigQuery Graph brings the power of graph analysis directly into your existing datasets, all with the speed and performance of BigQuery's optimized storage and query processing with a simple graph query language, or GQL for short. Check this out. We have our accounts table related to our customers table. We also have a table with transactions. With this command here, I have a graph where customers and accounts become the nodes and the relationships between them are the edges. We can now use this representation of the data to better recommend types of financial products or uncover fraudulent transactions. We can even apply advanced features like vector and full text search, as well as interoperability with SQL. And the best part, I didn't need to make copies of the data, I just used the existing tables. If you want to try this yourself or learn more about how graphs can help you uncover hidden relationships in your data or make your AI agents more powerful, check the links in the description.